Welcome to the DIY Honda Garage channel. Welcome to this diagnostic presentation on DTC P0443, which pertains to an issue with the EVAP Canister Purge valve circuit in the Honda Civic models from 2011 to 2015. The EVAP Canister Purge valve plays a crucial role in the vehicle's evaporative emission control system, which prevents fuel vapors from escaping into the atmosphere. Located in the engine compartment, the valve controls the flow of fuel vapors from the EVAP canister to the engine for combustion. When functioning correctly, it regulates these vapors, ensuring that the emissions remain within legal limits. A malfunction in this system can lead to increased emissions, affecting the vehicle's compliance with emissions regulations and potentially harming the environment. Today, we'll troubleshoot this issue step by step, starting with error verification and moving through potential fault areas that could lead to the DTC being triggered. The error described by DTC P0443 indicates a malfunction in the EVAP canister purge valve circuit. The main component involved is the EVAP canister purge valve itself, which is essential for managing the flow of fuel vapors from the EVAP canister to the engine. Its location is typically in the engine compartment, near the intake manifold, making it accessible for testing and replacement. As part of the evaporation emission control system, this valve helps prevent harmful fuel vapors from escaping into the environment. If the valve is stuck open or closed, it significantly impacts the vehicle's emissions, potentially triggering this diagnostic trouble code. In essence, the system's overall integrity is compromised, leading to increased emissions and a possible failure during emissions testing. There are several potential causes for the DTC P0443 to appear. First, the EVAP canister purge valve could be stuck open, allowing too much vapor flow. Or it could be stuck closed, which would obstruct vapor flow entirely. Both conditions can trigger the DTC. Additionally, faulty wiring can lead to interruptions in the circuit, causing the valve to operate incorrectly. Poor connections at the terminals of the valve or around the engine control module, ECM, or powertrain control module, PCM, can also result in this trouble code being set. Therefore, when troubleshooting, it is essential to consider both the mechanical functionality of the valve and the electrical integrity of the wiring and connections involved. When DTC P0443 is triggered, there are several symptoms a driver may experience. One of the most common indicators is the illumination of the check engine light on the dashboard. This warning signifies that the vehicle's onboard diagnostic system has detected an issue that needs attention. Additionally, the vehicle may experience a failed emissions test due to increased emissions from a malfunctioning purge valve. Another potential symptom might be a decrease in fuel efficiency, as improper vapor management can lead to less efficient engine operation. Understanding these symptoms helps in the early detection of the problem and may prevent further complications down the road. The first step in troubleshooting DTC P0443 is to verify the problem. Start by turning the ignition switch to on position 2 without starting the engine. Next, you'll use the Honda Diagnostic System, HDS, to clear any existing trouble codes. This process resets the system and prepares it for fresh monitoring. After clearing the codes, start the vehicle's engine and hold the engine speed at 3,000 RPM, ensuring the automatic transmission is in park or neutral. Maintain this speed until the radiator fan activates, then allow the engine to idle. Finally, check for any pending or confirmed DTCs with the HDS. If DTC P0443 appears, it indicates that the failure has been replicated, and you should proceed to the next step in the diagnostic process. In the second troubleshooting step, turn the ignition switch to the lock position 0 to begin. Allow the engine to cool to below 140 degrees Fahrenheit, 60 degrees Celsius for safety. Once the engine is cooled down, disconnect the vacuum hose from the EVAP Canister Purge valve located in the engine compartment. After the hose is disconnected, attach a vacuum pump gauge to it to check for vacuum levels. Start the engine and let it idle, carefully observing if a vacuum is present. If you detect vacuum flow, this indicates that the EVAP Canister Purge valve is likely stuck open. Further steps will focus on this diagnosis. Conversely, no vacuum present suggests that the valve is stuck closed, thus directing you to a different set of diagnostic procedures. In the third step of troubleshooting, again set the ignition switch to the lock position 0. This will ensure that no power is flowing through the system during your tests. Next, disconnect the 2P connector from the EVAP Canister Purge valve to isolate it from the circuit. With the connector disconnected, check for continuity between the designated test points using a multimeter. The test is performed under the condition that the ignition switch is in the lock position. This step will help identify if there is continuity in the PC sol line, which connects to the purge valve. If there's continuity, this suggests a potential issue exists with the PC sol line itself, warranting further investigation in the following steps. For the fourth step in the troubleshooting process, first jump the SCS line using the Honda Diagnostic System HDS to set up for the next test. After this step, disconnect the ECM-PCM connector B, which has 49 pins. This disconnection is necessary to isolate the electronic control unit for checking continuity. Again, you'll measure continuity between the specified test points while ensuring that the ignition switch is turned to the lock position. This step will help determine if there's a short in the PCSOL wire connecting the ECM-PCM to the purge valve. If continuity exists, this points towards a wiring issue that requires repair to ensure correct functionality of the circuit. In the fifth step, again switch the ignition to lock 0 and disconnect the EVAP Canister Purge valve 2P connector. This allows you to measure the voltage without interference. Next, switch the ignition to the on position 2. You will then measure the voltage between the designated test points on the EVAP Canister Purge valve, while ensuring the connector remains disconnected. This test helps confirm whether the IG1 ACG/IG1 PCS wire is functioning correctly. If battery voltage is present at the test points, it indicates that this part of the circuit is intact. However, if no voltage is found, repair of an open circuit in the IG1 ACG/IG1 PCS wire will be necessary, tracing the wire back to the 10A fuse located in the under-dash fuse relay box. Step 6 involves checking continuity once more, starting by switching the ignition to lock 0. After that, jump the SCS line using the HDS and disconnect the ECM-PCM connector B as previously done. With both the EVAP Canister Purge valve and the ECM-PCM connector disconnected, measure continuity at the specific test points defined for the PC sol line. The key aim here is to confirm whether the PC sol wire works correctly between the ECM-PCM and the purge valve. A confirmation of continuity indicates that the wiring is functional. However, if there is no continuity, repair is required on the PC sol line to ensure proper communication and operation of the purge valve within the system. The final troubleshooting step requires measuring the internal resistance of the EVAP Canister Purge valve. To carry out this test, ensure that the ignition switch is turned to the lock position and that both the EVAP Canister Purge valve connector and the ECM/PCM connector are disconnected. Measure the resistance between the two designated points on the purge valve connector. you want to see a reading of approximately 23 to 26 ohms at room temperature, which indicates that the valve is functioning properly. If the resistance falls within this range, it is advisable to check for the latest software updates for the ECM/PCM or replace it with a known good unit if it is not updated. If the resistance reading is outside this specified range, the next course of action would be to replace the EVAP Canister Purge valve to resolve the issue. Once you've completed the necessary repairs and replacements after troubleshooting DTC P0443, it is critical to verify the efficacy of those repairs. Start by turning the ignition switch to the lock position, and then carefully reconnect all connectors you previously disconnected. With everything in place, turn the ignition switch to on, too. You'll then reset the ECM/PCM using the HDS, which will clear any existing trouble codes and establish a fresh start for the vehicle's diagnostic system. Following this reset, it is essential to perform the ECM/PCM idle learn procedure. Finally, monitor the onboard diagnostics OBD status using the HDS. Ideally, the system should indicate passed. If it does, you have successfully resolved the issue. If the system displays failed, executing, or out of condition, further diagnosis may be necessary. In conclusion, DTC P0443 relates to a malfunction in the EVAP Canister Purge valve circuit, impacting the Honda Civic models from 2011 to 2015. Throughout our troubleshooting guide, we identified various steps with checks on both the mechanical and electrical components of the system. By understanding the potential causes and symptoms, technicians can effectively narrow down and address the issues related to this diagnostic trouble code. Regular vehicle checkups, particularly concerning emissions-related systems, are vital in ensuring compliance with regulations alongside optimal vehicle performance. Emphasizing preventive maintenance on the EVAP canister and associated components not only helps in avoiding these issues, but promotes a healthier environment by reducing vehicle emissions. Please like and subscribe to the channel. See you next time.